All right, welcome back, Hononegah Honors, Algebra 2, Section 6.6. This is day 2 on solving exponential and logarithmic equations. This is probably actually the most important day of the chapter. And so really you need a graphing calculator, or you need a calculator today. When it's not convenient to write each side with an exponential equation using the same base, you can try to solve the equation by taking the log of each side. That is an important statement. So if I can have 2 to the x equals 2 to the 7th, like we've done earlier in the chapter, then that's fine. That's the easy way, and I really don't have to do much. But what happens if I have a situation in which I can't get the bases to be the same? Okay, so it's impossible to get 3 and 5 to be the exact same base. So just like you've done a lot with equations, you have to do something to both sides of the equation, and you're going to take the log of each side of the equation. So 3 to the x is equal to 8. I can't get the bases to be the same, so I'm going to take a basic log of both sides of the equation. Now, one of the properties of logarithms states that if you have an exponent, you are allowed to move that exponent and times it by the logarithm. That is one of the most important rules about logarithms, is if you have a log raised to an exponent, then that exponent can be multiplied times the logarithmic function. The reason that's important is because now it's no longer an exponent, it is now part of the equation. It's x times log of 3. And so from what we've learned about equations, I can divide by the log of 3. And now it becomes a calculator exercise. On your calculator right now, you want to take log of 8. Now you need to be careful depending on your calculator. Log of 8, you're going to need to close the parenthesis and then divide by log of 3. And so 1.8928 rounding to 4 decimal places. And I believe on your test, it will say, it will say round to 4 decimal places. So A is easy, B gets really complicated. So we go from the basic question to obviously the most complicated question. I'm going to take the log of both sides. After I have taken the log of both sides, the exponents now can be times the logarithm. The trouble is the exponent on the second one is a binomial. So that binomial is out in front. Now, I would need to, and this is going to take us some time, so here we go. I'm going to need to distribute the log in here. So it actually becomes 5x times the log of 3 minus 3 log of 3. I need to get the x's on the same side. So I'm going to subtract 5x log 3. So now I've got 7x log 2 minus 5x log 3 is equal to negative 3 log 3. Now remember when we did factoring GCF, in this case I'm going to take a GCF out of both of these. I'm going to take out an x, which becomes x times 7 log 2 minus 5 log 3. So I was able to get the x's on the same side, take the x out of both of them. Now, because it's x times, using inverse operations, I can divide by that entire parenthesis to both sides. And I don't have a lot of space here, but 7 log 2 minus 5 log 3. So now, on a calculator, I'm going to move this thing out of the way here. On a calculator now, and again, you need to be very careful. Do negative 3 log of 3, and then I would hit enter on that, and then divide by, and then again, put that in parentheses, 7 log 2 minus 5 log 3. And so you got to be a little careful with your parentheses, but I get x to be 5.1415, rounding to 4 decimal places. So if the exponent is a binomial, it requires a lot more work. So if I have more than one x in the problem, I'm going to have to get the x's on the same side and then take the x out. Let's see if I can move this thing back here, get it out of the way. All right. If you have an e, instead of doing a log of both sides, you can actually do natural log. And to be honest, and I've talked to the calculus teachers, you actually can do natural log all the time, but I only do it when there's an e involved. So I have natural log e to the 2x, natural log of 8. Now, take the exponent. The natural log of e, you can do this on your calculator if you want, but the natural log of e is just 1. So now I have 2x is equal to natural log of 8. Divide by 2. And so natural log of 8 on my calculator. I hit enter to make sure that I just do the natural log of 8. Otherwise, you need to make sure you close the parentheses. Divided by 2, 1.0397. So isolate e first. So there's some things I can do in this question before I actually deal with the fact that there's an e raised to the negative 2x power. So notice I subtracted 4 from both sides. I divided both sides by 3. So now I'm going to take the natural log, and I'm showing my work here, natural log of both sides, and the exponent of the natural log goes out in front, and natural log of e is just 1. So divide by negative 2, and so then natural log of 2 divided by negative 2 is negative 0.3466. Again, rounding to 4 decimal places. Another property that you have to worry about, and there's some caveats to this one, because as long as b, x, and y are positive, then this works. And the base can't be 1. And don't get me, I will make sure that the base is not 1. But if you have a log, base 2 of x, equaling a log base 2 of 7, basically what happens is you're taking the anti-log of both sides, or the logs basically are gone. If you have a log equaling a log, then the arguments are equal to each other. So x would equal 7. And again, you're basically taking the inverse log or anti-log of both sides. So if I have natural log of 5x plus 2 is equal to natural log of x plus 10, then 5x plus 2 is equal to x plus 10, because the natural log, you're taking the inverse natural log of both sides. Subtract x and solve. Now, you always have to do a little bit of work here. If you remember right, I said these have to be positive. So if you get an answer that would cause those areas to be negative, then you have a problem. But in this case, x equaling 2 does not cause any problem to the natural logarithm, and therefore x equaling 2 answer is correct. But you should always double check that your answers don't cause an issue. Now, if there's not a log on both sides, then you have to do the spiral, or what we talked about previously. Base, power. So logs raised to the 3 raised to the 4th power would equal 10x minus 9. 3 to the 4th power is 81. And divide by 10. X would equal 7.2, or what would that be? 36/5. So there's 2 types of problems. I'm going to scroll down here. I'm going off script here a little bit. You're either going to have a log equaling another log, or you're going to have a log equaling a number. In this case, you just get rid of the logarithms, or the anti-log of both sides, and make the arguments equal. In this case, you have to worry about the base raised to the exponent equals the argument. So again, there are 2 types of problems that we're going to work with. Now, we're going to add steps in the beginning, but there's really only 2 types of problems. You're either going to have a log equaling a log, or a log equaling a number. So here we go. I have a natural log equaling a number. Remember, all natural logs are based e. So this becomes e to the third equals 2x plus 5. Now, e to the third, remember, e is an actual number. So I'm going to pull out my calculator and go e raised to the third and get 20.0855. And now it's just a regular algebra question. I'm going to subtract 5 and get 15.0855. And then I'm going to divide by 2. 7.5428 if I round to 4 decimal places. Now, inequalities, and again, there's a little bit of a caveat that you really got to worry about. If b, x, and y are positive and b is greater than 1, meaning the base is greater than 1, then this is true. And log base b of x is greater than log base b of y. Now, you do have to be careful for domain, meaning if you got a less than or greater than, that might cause the arguments to be negative. You do have a domain issue. So off to the side here, I'm going to put my domains. So 3x minus 4 must be greater than 0. So my domain for the first one has to be greater than 4/3. My domain for the second one, x must be greater than -6. So there's 2 domains that we have to worry about here. Now the actual solve. I'm going to take the anti-log of both sides, and I'm going to solve this. X is less than 5. Now, if I were to do this on a number line, I have 3 things to worry about. And remember, it has to be true for all 3 in order for this to work. So I'm going to do a little number line here. I've got 4/3, and we're talking about greater than that one. I've got -6, and greater than that one. And 5, and less than that one. So what area is true for all of them? Well, as long as it's greater than 4/3, but less than 5. So as long as it's between those 2 numbers, it's in this area right here, that is true for all 3. Now, I'm not worried about the graph. I'm merely worried about the solution, but the graph may help you see the area that is true for all of them. So this is a little bit of a, you got to be careful here to make sure you get the correct answer. Let's solve this inequality. Now, taking the log of both sides does not cause an issue, by the way, to the inequality. And I'm going to move this out in front because that is one of our rules of logarithms. And I'm going to divide by the log of 3. So now, log of 20 on a calculator. And then I'm going to divide that by log of 3 on a calculator. And 2.7268. Now, some of you are going to say, look at the original question. Is there a domain situation with the original question? Am I allowed to have positive values of x? Yes. Am I allowed to have negative values of x? Yes. So therefore, there is no domain issue. There's never a situation in which you have a log in which the x is the argument. So you do not have any domain issues if you take the log of both sides. If there's no log in the original question, there is no domain issue. Here there's a domain issue, right? I have a log, and the argument is x plus 2. So the domain is x must be greater than or equal to -2. Now, this is a little bit of a caveat with the spiral technique. And I always debate this all the time. 3 is going to be raised to the third. The trouble is, how do I do the inequality symbol? So I have 3 to the third, but the x plus 2 is less than or equal to. Now, I don't know which way you guys want to deal with this, but ultimately, the x plus 2 is less than or equal to. You see this little part right here? The x plus 2 is less than or equal to. That must stay the same. The less than symbol is pointing at x plus 2. So that has to stay the same. So I don't know if you want to write it as x plus 2 is less than or equal to 3 to the third. That makes no difference to me. But I'm going to go ahead and solve this. So 3 to the third is 27. 27 minus 2 is 25. Now, x has to be greater than negative 2. And the answer is x is less than or equal to less than or equal to 25. So this is greater than negative 2. Homework assignment is out of the book. If you have any questions, make sure you talk to your teacher. This is the section, so please make sure that you're watching this video, that you are understanding this, and good